Tech Talk Platform Edition today. We're going to give folks just a minute to get rolled and signed in. So bear with us for just a moment and we'll hit the ground running very shortly here. Perfect. I can see folks coming in already. Perfect. Well, let's hop right in. Thank you, everyone, for joining today. Like I said before, this is one of our Platform Edition Tech Talks. The goal for today, we want to walk you through deployment server essentials, right? I'll give you a little bit of background on my role very shortly, but I find this to be one of the most critical skills when you're getting started with Splunk or when you're walking through typical administration, gathering new data sources, managing your environment, filtering. A very simple tool, but an extremely effective one when we're talking about your Splunk infrastructure. Before we get too ahead of ourselves, though, I want to quickly introduce myself. My name's Sterling Trafford. I'm a solutions engineer here at Splunk. So I'm in sort of a unique role where I work with customers all the way up to multiple terabytes and even customers that are 5 to 10 gigabytes. So pretty widespread experience pool there. And hopefully we have folks from a number of different backgrounds joining the call today. A little bit more about myself. Been using Splunk now for about 6.5 years. I've actually been here at Splunk for 3 of those. So funnily enough, was a prior Splunk customer in a security analyst role. So I have a lot of experience with sort of the security use cases when we talk about things like the InfoSec application, enterprise security, et cetera. Now, we won't be talking about those things today. We're talking about something a bit more foundational with Splunk that applies to every use case, again, that being the deployment server, data ingestion fundamentals, and really how we tackle and navigate that entire area. Now, a bit on the agenda. First, we're going to start off, what is a deployment server? A little out of order here. I'm going to go off script a bit. We're going to go to the 3 main categories of data ingestion because I find those very important to really get your head around what am I using the deployment server for? Should I be using the deployment server? Et cetera, and so forth. Then we'll talk about common architectures, right? Regardless of whether you're a cloud customer, whether you're an on-premise customer, where does this fit into your environment? And then we're going to go through a live walkthrough of setting up server classes. We're actually going to start from scratch. So no fancy visualizations, no fancy stuff. I'm going to put myself in the shoes of a person just attempting to get a deployment server configured and their first package pushed out. So we'll start with some bare bones fundamentals. We'll also walk through in the demo itself is walking through conceptually, right? Taking a step back, how do we plan out data ingestion to make it more simple for you to tackle it yourself, right? How do you start to, at the end of the day, assign specific data sources to specific categories, giving you an easy avenue and sort of a template to attack getting it into Splunk. Awesome. We've got a quick question for the audience before we get too ahead of ourselves. I'm curious how much experience you have with the Splunk deployment server. Have you heard of it before? Have you never heard of it? Have you used it many times? Do you consider yourself an expert? Would love to hear some feedback here, and we'll wait about 15, 20 seconds to give you time to answer. Now, the goal for today's call, regardless of your experience level, to give you some useful information. So if you've never touched it before, I think you'll get a lot of value. And if you consider yourself an expert, I certainly hope to share some details with you that may even round out that expertise. Awesome. It looks like we've got some numbers in here. About 10% of the crowd has never heard of the deployment server. 40% has never implemented one. And another about 35 to 40 needs help with configuration. Awesome. Well, that makes me excited. I think the team will get a lot of use out of today's call. One more question for you. Do you plan to leverage Splunk Cloud or Splunk Enterprise? Now, the deployment server's functionality is going to be identical between the two, but it does slightly change your thought process when you go to implement, and specifically where you go to place the deployment server. So we'd love to hear where the team sits here as well. Awesome. Let's check here. It looks about 50-50. All right, about what we would expect. So we'll certainly cover deployment topologies for both of those. Awesome, awesome. Well, let's get into the fun stuff. First, before we talk too much about a deployment server, I want to explain why should you care. Specifically, if you're in that crowd that said, hey, I've never used a Splunk deployment server, or I'm looking for help with configuration, I really want to convince you today of the power of the Splunk deployment server. So what does it look like without a deployment server, and what does it look like with a deployment server? Without a deployment server, first and foremost, manual implementation of configuration on each forwarder. What does this mean for you? I'm going to use a basic example here. Let's say we've got 7 domain controllers. I go out, I install the Splunk Universal Forwarder on each, and then I say, okay, let me go install the Windows add-on on top of those. Your job then is to install the Windows add-on on every single system, right? Ensure that configuration is identical. So when we hop down to step 2, ensuring consistency, that means if you make a change, you say, hey, I enabled XYZ input, I want to grab advanced firewall information, right? I'm going to have to go on top and say, well, I need to go do that on each and every forwarder. So my job becomes much more manual. I've got to visit each individual device. I've got to ensure consistency between those. Obviously, we hop down to step 3. That's going to be time consuming, especially as you scale, right? Visiting each system, adding new sources. Let's say 6-12 months down the road, I go in and I say, well, we need to grab an additional data source from our web server. We need to grab an additional source from our domain controller. I've got to go get an inventory of all of those, visit each one individually, and change. Certainly, we want to move towards the deployment server topology, wherein we make a single click of a button, right? We add the application to a server class, wink, wink. We'll talk about that very shortly here. And it's pushed out to all systems in which we designate. Obviously, at the end of the day, the big thing here is the big pain point we're trying to solve with a deployment server is it's extremely time consuming and tedious to manage many devices as you scale when we talk about not using a deployment server. So first up, what is a deployment server? So deployment server, in short, is really just a simple device. Again, a management device for your forwarding. It helps you deliver new add-ons. It actually helps you filter your inputs. We'll talk, and I'll hint towards the team today a number of different ways in which we can filter. So if you've heard of ingest actions before, you may hear of them a little bit on today's call as well. It allows for programmatic introduction of new clients. So again, if I have 7 domain controllers and suddenly I added 8th and 9th and 10th, 8th and 9th and 10th web server, whatever the case may be, it immediately gets identical configuration to the rest of my infrastructure, allowing it to smoothly flow up into your Splunk deployment. Also allows for saving and storing of configuration. So you don't have to worry about what did I configure on device A? And what did I put there? How do I need to add new ones? So essentially making that whole process much simpler. We'll talk in detail about the diagram that I have for you here. You'll notice 2 sort of words to know. That would be server classes and deployment clients. We'll talk about those in more detail in just a bit. Before we get too deep into the deployment server, however, I think it's especially helpful to really understand when we talk about getting data into Splunk, what kind of categories, how can we categorize that, and how can we make it more digestible? So when we look at all the different data sources that Splunk can ingest, they really fall into one of 3 categories, right? 99.9% are going to be either syslog-based, API or HEC, HTTP event collector-based, or agent-based. Agent-based meaning the Splunk forwarder. And so when we talk about the deployment server, it's typically leveraged for that 3rd category, for the agent-based, for managing those forwarders, for managing those individual endpoints. However, it is often also used for setting up the add-ons and applications needed for syslog-based or API-based. So I'll walk you through, when we get through the demo portion today, an example of my thought process when we attack each of these. Now, the reason why I find it so important to know this is if I'm sitting down suddenly I decide, hey, I need to go grab a new data type. The second I'm able to categorize it into one of these three fundamental data ingestion categories, it becomes much easier for me to make a whole game plan, start to finish. How do I get that data into Splunk? So I really want to get, if you get anything from today's call, I really want to get that across to you and how you can use the deployment server to actually implement that. So let's walk through each of those. Agent-based ingestion, the most common form of ingestion when we talk about Splunk. When am I going to use data ingestion, or excuse me, agent-based ingestion? I'm going to use agent-based ingestion anytime I'm able to get a forwarder on the system and I'm able to access individual files, logs, ports, etc. on the system. So typically, the two types of agent-based ingestion you'll see are the universal forwarder and the heavy forwarder. When we look at Splunk in general, there are only two Splunk installs, right? There is the Splunk Forwarder install, and then there's the Splunk Enterprise install. So if you're not familiar with what a heavy forwarder is, it's simply a Splunk Enterprise install that has been configured only for forwarding. You'll commonly see that used when we talk about syslog in just a moment. Examples of agent-based ingestion would be things like Windows Event Log, web servers, live application logs. Again, anything wherein I'm able to get an agent on the system, and from there able to grab the logging that I'm looking to push up into Splunk. Key thing to know about the agent-based ingestion, very lightweight device. The universal forwarder is only going to be doing network operations on top of the data, no transformations, no changes to the data itself. Now our second form, our syslog TCP UDP-based ingestion. This is typically when you're going to use that Splunk heavy forwarder to actually listen for that syslog traffic coming into Splunk. So some examples of this would be routing and switching, firewall logging, IDS, IPS logging. Again, data sources we're in. You cannot get a forwarder on the system. I'm not going to be able to install a Splunk Universal Forwarder on my firewall. I'm going to need to configure some form of syslog-based ingestion to get that into Splunk. Now, we won't talk in too much detail today about Splunk Connect for syslog, but Splunk Connect for syslog is a very scalable way to manage multiple syslog or multiple TCP UDP-based ingestion forms, especially as you scale. So certainly want to get you some documentation, and you'll find that towards the end of the call if you find yourself in the boat of having many of those and looking for an easier way to manage them. Now, the last form of ingestion before we hop back into the deployment server would be HTTP-based ingestion. Now, you're most commonly going to see this in the case of cloud data sources, right? AWS, Azure, Google Cloud. You'll also see this for some EDR solutions, right? So CrowdStrike being an example, Cisco AMP being an example, or now I believe it's called Secure Endpoint, wherein you're not able to get a forwarder on the system, and you're also not able to get syslog out from it. You're able to get HTTP out. So that's the method you would use in that case. If you're noticing the trend here, at the end of the day, or we like to say Splunk's going to be able to handle any of the logging you throw at it. It's just a matter of determining, first step, we're going to grab a new data source, determine how does that vendor, how does that tool, that solution present the data to us. Based on that, let's align it into one of these three categories, and we have a game plan for actually getting it into Splunk. Now, next slide, diving back into the deployment server. Where does the deployment server fall into this? So the deployment server is going to be managing those forwarders. It's going to be managing those agents. How does it do it? What the deployment server is doing, and you'll see it in this graph here, is it's saying, hey, in my head, in my configuration, I've got some different server classes. These server classes map clients to specific Splunk applications. So for instance, our server class here for Windows might say, okay, I'm looking specifically for systems with a Windows type that fall under a specific IP range, and I'm going to send out a pre-made package of Windows add-ons to configure Windows inputs. The same thing goes for Linux and the SFUK you see here as well. So if that doesn't make sense quite yet, it should make sense after we've walked through a demo of it as well. Now, where do we place this forwarder? Right. I'm going to show you an example for cloud. I'm also going to show you an example for on-prem. So essentially with the cloud, right, when we talk about Splunk on-prem and Splunk cloud, in the past there were some differences as far as functionality. Those differences have really all been solved, and we lie in a state where fundamentally, functionally, between cloud and on-prem, near identical functionality from Splunk. The differences come in, again, in who's responsible for different systems. So everything above that bottom box is completely abstracted away from you, right? That's what Splunk Cloud's handling for you. Now you'll see the deployment server there at the bottom in front of your collection tier. So the key thing to keep in mind when we're talking about cloud is your deployment server needs to be in a location wherein it can reach Splunk Cloud, and additionally, it can reach your forwarders. So if you find yourself in a situation when we talk about more complex topologies with network segments, very rare, but it could be the case that you would need two deployment servers in the case that there are two network segments that you cannot talk to at the same time, right? You cannot have a device with network access to both of them. And I'll show you very shortly here what I mean by network access. It's just two specific ports for Splunk GCP. Now, common architectures on-prem. I'm showing you here really our most scalable architecture. So this would be an architecture designed for close to a terabyte of data per day, maybe even more, right? This is essentially a search head clustered and indexer clustered environment. However, that has no implication on the deployment server itself. Again, the deployment server in this topology, regardless of how many indexers, how many search heads you have, whether it be 1 or whether it be 50, the deployment server needs to be in a location. You'll find it there in the top left on our diagram. It needs to be in a location wherein it can reach all of our agents that we want to manage. So again, it could be the case in network segmentation that you need to do two. Very rare, but we have seen that before. Now, planning the implementation of a DS. Now that we really know where it sits within the architecture itself, what do we need and what do I mean when I say it needs to be able to connect to the agents? Well, it needs two specific ports. It must be reachable via the actual clients. And by clients, I mean the Splunk forwarders, that being either a heavy forwarder or a universal forwarder on 8089. That is the Splunk management port. It's going to handle all of the delivery of Splunk applications. Again, Splunk applications simply being a fancy name for bundles of configuration. Preferably, it can reach your indexers outbound on, and this is actually a typo here, that should be 9997. That's going to be the default Splunk data forwarding port, right? The reasoning behind that is if you do if you do send your deployment server logging to Splunk, you're then able to, in your monitoring console, right, in your underscore internal data, you're able to actually monitor the performance of your deployment server, the applications that have been pushed out, et cetera. So not mandatory, certainly recommended that you do forward your deployment service logs even to your underlying infrastructure, whether that be in Splunk Cloud or on-prem, again, forwarding that to your indexers. Now, for resource specifications, we'll have that attached for you. And a key thing to keep in mind, you must have CLI access to the system to manage the applications themselves. From the UI, and I'll show you an example of this today, we can manage what applications are shipped to what systems. We can change server classes. We can do all that fun stuff. But we must have CLI access to the system to actually modify the applications, to change the inputs.conf, to change the props.conf outputs, whatever the case may be, that we're forwarding to those clients. Importantly, you're likely familiar with the Splunk Home directory of Splunk Home Etsy apps. That's where all of your apps are placed, whether you download them from Splunkbase directly in your UI or you place them via the command line onto your device. They're going to go into Etsy apps. All the deployment server is doing is it's saying, I'm going to check, instead of the apps directory, I'm going to check the deployment apps directory for applications. I'm going to assign those applications to specific clients, and I'm going to push them to the apps directory on the clients, right? So active applications will always be in the apps folder. The deployment apps folder is a staging directory for your clients. Awesome. So with that out the way, we're going to leave the remainder of our time today to hop into an in-depth demo. Now, the goal for the demo here, what we're going to start out with is I'm going to walk you through first, before we talk about the deployment server, an example of my thought process when I go to set up an agent-based ingestion format, when I go to set up a syslog-based ingestion format, as well as when I go to set up a HTTP event collector-based format. I think it's very helpful to sort of understand and templatize how you attack those individual data ingestion problems. That way in the future, when you say, hey, I've got to go get in Sterling Fun project A data source, you understand exactly how to do so. You can slot it into one of those three categories and tackle it from there. So no fun, or excuse me, no crazy visualizations from here on out. I'm going to throw you right into the melting pot with me. I'm going to share my screen. We'll do some Google searches. We'll do some Splunk-based searches, and I'll show you my thought process before we hop into the demo. So give me one moment, and I will start my screen share, and we will hop right in. Awesome. You should be able to see here. So we've got our UI here. First thing I want to tackle, we're going to visit Splunk base, and we're going to say, hey, I've got maybe Palo. I've got Palo logging I want to bring into Splunk. This will fall into that syslog format of ingestion. How do I do that? How do I tackle specific Palo? So first thing I would do is I'd say, okay, let's go take a look at splunkbase.com. You'll see two things. You'll see an add-on for Splunk, and you'll see the application for Splunk. In short, add-ons are responsible for data ingestion, normalization of the data, and making it ready for Splunk. So when we talk about tools like enterprise security, we talk about tools and applications like the InfoSec app for Splunk. They're going to require you to have the add-ons to normalize data. Now, that's really out of scope for today's call, but we wanted to take a brief aside and explain that to you. So importantly, when we're talking about ingesting Palo data, we're going to look at the Splunk add-on. Now I'll take a look at the documentation page. I'll click details. I see an installation guide. Perhaps I want to take a look at it. And it becomes very obvious for me here shortly, we scroll down, that this is going to be leveraging, getting data into Splunk. This is going to be leveraging either the HTTP event collection format, if I'm using something like Cortex Data Lake, or for the firewall and panorama section, it's going to be using syslog. So I can very quickly, you're showing that thought process again, I can very quickly say, okay, well, this is syslog-based ingestion. It's going to require me to open a port on my Splunk forwarder and pull that data up into Splunk. Now, if I wanted to deploy this application, for instance, out to a forwarder, we'll show you that in just a bit. To show you another example of how we would attack getting data into Splunk, let's try a cloud data source. So perhaps I'm looking to get Azure data into Splunk. I'm going to look up the Splunk for either the 365 or the Azure add-on. Let's do that just right here. Splunk add-on for Azure. In this case, we're again, our first goal, let's figure out if this is syslog based. Let's figure out if this is HTTP based, or figure out if this is agent based. Scrolling down here, we'll see the different items that the add-on collects. I'll go to details and take a look at the documentation. And we should be able to see here some alert actions that are supplied by the add-on, as well as which category it falls under. So let's back up here. Devices includes all the new values. Where does it tell us that we are using the API? Oh, here we go. The install documentation. Where to install the add-on. So this will tell you where and what devices to install on. It'll also walk you through how the data is ingested. In this case, again, this is going to be actual HTTP-based ingestion using the Azure API. So similar things like AWS, GCP, Azure 365, again, all going to use that HTTP-based ingestion. Now for our last example, let's tackle agent-based ingestion. So agent-based ingestion would be things like the Splunk add-on for Microsoft Windows, things like the Splunk add-on for Unix and Linux. And this is immediately going to signal me that, hey, we want to involve the deployment server to push out this add-on to our underlying system. So I'll take a look at the Splunk add-on for Windows. I'll take a look at the details and the documentation, and it'll become immediately apparent to me that this is leveraged for endpoints or servers, as I see the list here. If I take a look at configuration, I'll also see how I would configure things like inputs.conf to filter specific files that this add-on will be pulling into Splunk, which is something I may want to do as I send this out to my endpoints. Now, for today's demo, what we're actually going to be walking through an example of is not Windows data. However, it's applied in the exact same way. we'll be walking through an example of specifically Unix and Linux data. So let's do just that. I just sat down. I've got my two systems here that I am looking to set up the deployment server on. You'll notice here, if I go to my home directory on the top, this is our deployment server. So the top left is our deployment server. And if I go to the home directory on this device, I'll find that this here is my forwarder. I've got two systems. I've got a deployment server, and I've got a forwarder that I want to connect to that deployment server. If you've never touched the Splunk command line before, you'll also get a bit of information about that today, specifically how you configure the deployment server or a forwarder. Now, the default directory, if you look at any Splunk documentation, will have this attached at the end of the call as well. To install Splunk is typically opt Splunk when we're talking about Unix or Linux systems. Now, if you install this on Windows, you'll actually get a UI that walks you through the exact steps I'm going to show you today. So no worries there. Once you really understand the steps themselves, Windows makes it even simpler for you to do so. First thing we want to do is say, okay, I need to get the Splunk forwarder on our system. I'm going to go to the opt directory. You notice I have already installed the Splunk forwarder here, and here is the tar.gz file that I used to install it. Now, if I'm looking to get the Splunk forwarder, it's as simple as visiting splunk.com. So let's do just that. We're going to say, hey, I want Splunk forwarder install. You'll sign in here on splunk.com, and they will give you that download. They'll give it to you in two forms. One, they'll give you the download directly to your existing system, and two, they'll give you a wget command to install it. So I typically go the wget direction, which is actually how we got this TGZ file. It's as simple as untarring that file to get the Splunk forwarder directory. We'll migrate into our Splunk forwarder directory, and let's take a look at the file structure. We've got our bin directory, we've got our etc directory. We want to make sure that Splunk has been started, so let's migrate over to the bin directory and run /Splunk. ./Splunk status. Looks like Splunk is running. So all we need to do from here to show you how simple it is to go from installing the forwarder to getting it remotely manageable is setting the deployment server location. So to set the deployment server location, we run a very simple Splunk command, /Splunk set deploy -poll. This command allows you to tell Splunk, okay, when you're phoning home, when you're looking for your deployment server, Mr. Forwarder, you're going to reach out to the set address that I will be giving you here. Now, that specific address for me is going to be this EC2 instance. I will paste right here. And you also have to keep in mind that you must explicitly set port 8089 as that is the management port for Splunk. Now, very uncommon. You technically could change that port. Obviously, you would know if you had changed that port. And if you did so, you'd ensure that you leveraged the port in which you switched that to. So we will set that as our deployment poll. And we know Splunk is on. So let's migrate over here to our other instance. This is our deployment server itself. Go to the opt directory. Let's go to Splunk. Check the status of this system. We'll cd to the bin directory, /Splunk status. And it looks like it's running as well. So now let's hop over into the UI and see and verify that these two devices have been connected. Last thing, actually, before we do so, I want to mention two things to keep in mind if you do experience issues with this. First and foremost, firewall rules. Anytime I'm working with customers and we're troubleshooting something around a forwarder or deployment server, firewall rules are going to be your worst enemy. So you must ensure, one, you set your local firewall rules. In this case, UFW is what I'm leveraging. So I could do sudo UFW allow 2 ports, 8089 TCP. I've actually already enabled. I'm just writing it out for you here. And I would also need to enable 9997 via TCP, right? The 2 ports that are needed for a forwarder. 1, 8089 to connect to the deployment server, and 2, 9997 to connect to the indexers. Also keep in mind, that's my local directory. That's my local forwarder. I'm also going to want to ensure that I've also set my external firewall. So in this case, my external firewall is actually AWS. You'll notice I've set a specific security group that gives me access to ports 8089 as well as 997. That's also a big gotcha. Certainly want to ensure your external firewall is allowing this traffic as well. Well, now that we have access to Splunk, let's log in. So we're now logged into this system in the top left, that CLI instance. We're now logged in there. Here's our Splunk environment. Where do we go to ensure that our forwarder is connected? If we migrate over here to our settings, we will find a section called Forwarder Management. Within Forwarder Management, we'll see a list of all of our clients, how many deployment errors we have, and the total number of downloads. Now, downloads would be downloads of the forwarders being shipped applications. We already see our first client here. We see that no applications are deployed. Let's fix that. Let's deploy our first application out to our clients. And we're going to do so through creating, a server class. Again, server classes are just logical mappings of configuration to sets of clients. So let's create our first. I'm going to create one, and I'm going to call this one all_outputs. Now, this is not mandatory, but let me explain my reasoning to you behind this. I like to decouple configurations that are based around actually where the data is forwarded from what data is gathered. So all outputs is a very simple app that's being pushed out. It's just telling the forwarder, here's where you send the data. So in your case, your all outputs would say, hey, you send the data to splunkcloud.com, right? And your relevant infrastructure behind Splunk Cloud. If you do visit Splunk Cloud, you'll see a download of an application pre-configured for you. It's the Splunk Universal Forwarder application that can do just this. You place that on your deployment server. Now, two things we need to add. Again, server classes are a logical mapping between applications for configuration and clients. We're going to add our first application, that being outputs all. One more gotcha I've got for you here, however. If we take a look at our applications, there are some settings we can set for them as they are deployed out. If you deploy out an app and you say, hey, I don't see the data from that application, like, why is it not running? Why am I not seeing the new outputs.conf? Why am I not seeing the new inputs.conf? It's likely because that specific application requires Splunk D on the forwarder to be restarted. So I certainly recommend you enable restart of Splunk D on any applications that should require them. Hint would be most do, right? So most applications are going to require you to restart Splunk D on the forwarder to do so. So now we've got that enabled. The deployment server is going to tell our client to enable the application. It's also going to tell the client to restart Splunk D. Here's our server class. One thing I want to do before we connect that server class is show you that we do not have any data flowing into Splunk now. So we'll go to search and reporting. One easy way to check if systems are sending their data to Splunk is check for the _internal data. We're going to look for index equals _internal. And we'll find here that we only have one host. We have our local devices logging. That's all that's been connected. We'll go back to our forwarder management, and we'll finish setting up this server class. We've already added an application. Let's now add clients to that server class. I'm going to click Edit. I'm going to click Edit Clients. And I'm now brought to a screen where I can set whitelist, blacklist based upon the IP address, the host name, as well as the machine type. So machine type will be automatically populated based upon the devices that you've already sent and connected to the deployment server. So I only see Linux as I've only connected a Linux device. Assuming I connected a Windows device, you'd see that as well. In this case, I'm going to say I want to filter by machine type, and I want to include all of those machine types. I actually won't even filter this one to Linux because this is my all outputs, and I want this going to both Linux and Windows forwarders. I'm going to preview that this is shipped out to my correct client, and it looks like it is. We got a match here on our left side. I will now save this, and we will wait just a moment while our download is pushed out. We're not going to wait too long, however, because we're not just going to set up all outputs today. We're also going to set up the Linux add-on for Splunk. Now, again, If you recall from our presentation, we have to get any applications that we want the deployment server to push out into the deployment apps. You'll see it up here, the repository location, the deployment apps directory. So that means if I want to go to Splunk base and I want to get this add-on for Unix and Linux, I have two options. I'm going to show you the easy way, and I'll show you the not hard way, but just the not as easy way. The not as easy way is downloading it from Splunk base and let's say SCPing it over to your deployment server or file sharing it over. The easy way is just going into Splunk and downloading the application. So I've downloaded the Splunk add-on for Unix and Linux, which means I can simply come over here. I'll back up to the etc directory. We'll go to cd etc apps. And you'll find that I have in my app list here, I have the Splunk TA Nix, which is actually the Linux add-on. I'll take that and I'll cp-r Splunk_TA_Nix to / deployment apps. So I'm just copying a version of that application over into the deployment apps. And then I will run a command /opt Splunk bin. This is important. We could either restart or run this command to tell the deployment server, hey, we've got new add-ons, reload that add-on list. We'll do reload deploy-server. And we actually need to put bin Splunk here. I'll need to log in. I'll give my username and password to this device. And now we've reloaded all the server classes. Back in the UI. We're now back in our UI. Let's refresh the page. No clients phoned home. This is because we just now reset the deployment server. We also see the introduction of our Splunk TA Nix. Now, a piece of information for you here. The default poll for Splunk for the forwarders can be changed to the deployment server. I could be incorrect in this. I believe it's 60 seconds by default. So each forwarder every 60 seconds is going to reach out to the deployment server and pull any new configurations. So we should see in the next 60 seconds here that those clients have phoned home. And it looks like it phoned home just a few seconds ago, and we have confirmed that our application was deployed. How can we further confirm it? Well, we know that application contained forwarding information. Let's check and see if search and reporting now has data from our forwarder. We'll do index =_ internal one more time. Looks like we have one host here. So let's go visit that forwarder and take a look at it. We know our forwarder is in the bottom right. We can tell because the actual install is /opt/Splunk forwarder. Let's back up here. We're going to ls, and we are going to take a look at our applications directory. So etc apps. It looks like our outputs all is here. So let's take a look at what's in it, that application we shipped out. You recall the directory structure for an application. There are two important files, or two important directories, excuse me, the local directory and the default directory. I created this application, so there is only a local. When you download an application from Splunk base, you will see both. The local directory is where you put your configurations. The default directory is going to be configurations that Splunk has default shipped out to you. So we're going to go into local, and we will see our inputs.conf. I'm going to vim that and make sure we have correct information there. Looks like we do. So I'll give you another troubleshooting command here. We'll do /opt Splunk forwarder bin, and we will say list forward -servers. We'll do the bin directory, and then we will do Splunk. Oh, it's forward -server. We'll give our Splunk username. And it looks like we need to, I actually, funnily enough, ran into the same issue that I mentioned to the team earlier today. Because I shipped out the add-on before I set enable restart of Splunk, the add-on that I shipped out did not get enabled. So we will have to do opt Splunk forwarder bin Splunk, restart. We'll restart Splunk on this device. You now see, I walked you through intentionally, you can now see exactly what would happen assuming you didn't enable that enable app in time like we did before. So, or excuse me, that restart application. So just to circle back here, we go back into our Splunk UI, we go over into our forwarder management. We see our two applications. We have Splunk D restart enabled. Now, before we ship out our second one, let's set up Splunk D to restart so we don't run into that same issue. We actually need to create a server class for that, so we'll do that in just a moment. Now that Splunk has restarted, we can visit our individual systems. Here is our forwarder again at the bottom, opt, Splunk forwarder, bin, and we will do Splunk list forward dash server. Looks like I may have a syntax error there. So I will show you another Splunk command, //Splunk. We're in the wrong directory, /opt Splunk bin Splunk add forward dash server. We will give the location of our Splunk forwarder. Now I'll tell you exactly what that location is. Let's pull up our UI. We'll go over into our AWS. My EC2 dashboard will have that information for me. This is our location. I could have just as easily grabbed our UI here instead of 48,000 done 9997. We'll list this here at port 9997. Awesome. Now, if we rerun our list forward server, we'll see our configured but inactive. It will be active here very shortly. Awesome. Going back into our Splunk UI, I mentioned we want to set up the creation of a second server class here, specifically a server class designed to pull in our Linux data. Let's do just that. Let's create a new server class. New server class. I'm going to say Linux _outputs _all. Now, as you get more familiar with configurations in Splunk, you'll know that there are different types of configuration files. The important ones for forwarders are typically your outputs.conf and your inputs.conf. Inputs.conf is going to tell the forwarder what to grab. Outputs.conf is going to tell your forwarder where to send it. We're going to save this, and very similar to before, we're going to add our clients and add our applications. So I'm going to add our TA NICs. Also going to add our clients. In this case, this time I'll set our filter to be Linux x86. And I'm going to say this should forward to any and all Linux devices. I'm going to check that our preview matches. It does. I'm going to save this. And we've got one app in the server class. We need to enable our restart of Splunk D, which we now have. So we should see very shortly that two applications have been deployed out to our client. Let's take a look. We'll back up here. We'll CD into /opt Splunk forwarder etc apps. Again, apps directory is where it should be placed. We'll ls-al, and it looks like we have our outputs all, and we may still be waiting on our NICs. So we'll wait just a moment here to see when our NICs input shows up here. And there it is. We'll see that we have the outputs all right here, our first application. We'll also see we now have our Splunk TA NICs. So we now have the configuration needed to ingest Splunk NICs data. Now I'm going to walk you through here. Let's say we're in the boat where we say, I want to customize what's in the NICs application. For some of my Linux devices, I want to include all Linux configuration. I want to grab everything from bash history to open ports to process information to file monitoring on the system. right? But on others, I just want to grab a subset of that. How do we do that? Very easy to do. We'll go over into our deployment apps directory on the deployment server. So we'll go opt, Splunk, Etsy, deployment apps. What we need to do is create a copy of our TA NICs that has a subset of the configuration designed for our lightweight, we'll call them our lightweight NICs devices, where we're only grabbing a few data inputs, and make a server class called Splunk NICs Lightweight. I'll CP our directory here. We'll do CP-R Splunk TA NICs into a Splunk TA NICs underscore light. Now we're going to CD into our Splunk TA NICs underscore light. I'm not going to get into the full detail and breadth of explaining to you exactly how I'm configuring the inputs.conf. The individual applications will display that for you. So to give you a brief rundown of what we're doing here, if I was to visit the documentation page for the Splunk add-on for Linux, I could take a look at details, take a look at the docs. Specifically on the left side here, we'll see how to install. What we're looking for now is how to configure. We can see all the metrics we'd like to configure. We'll see the varying inputs that are able to be set up. And if we back up, we'll even see here a list of all the scripted inputs in which we can choose to set up. So for each individual one of these, I can say, turn this on, turn this off, enable this, disable that. Again, this circles back to our initial conversation around 6 months down the road, 12 months down the road. You may come to the conclusion that, hey, I really wish I had my interfaces.sh, right? I wish I got information on vmessage, ftool, ifconfig, LAN scan, LAN admin, but I don't now. Oh no, I don't have a deployment server. I need to visit my 72 Linux devices and configure that manually. No. Let's set up the deployment server and let's in one location do just that. So to do that, we could back up here. We'll go to our new version of the application. I'm going to ls here for us. We're going to go into our local directory, and we're going to take a look. Looks like nothing's in the local directory. What do? We back up to our default. This will have a default version of our inputs.conf. This is where I find and can enable those specific inputs. So we'll see them here: script vmstat metric, script iostat metric, ps. For demonstration purposes, I'm going to grab just 2 of these here. We'll copy them. We're going to go over back into our local directory. Again, local configurations are saved in the local directory. Never save your configurations to the default. The reason being, a year later, a new admin comes in. They update the Splunk application for Unix, Linux. All your configurations default will be wiped by the updated new configurations to be placed in default. Local will not. So we'll vim our inputs.conf. I'm going to paste in our 2 scripts that we'd like to enable. And we're going to run that fancy schmancy command from earlier: opt splunk bin splunk reload deploy -server. And all the commands from today's call will be attached to the end. I'll show you a link to that documentation before we close out that show you and can remind you of everything we've done today. Opt splunk bin splunk reload deploy -server. We're going to run that. Looks like those server classes have reloaded. And if we visit the UI now, which we'll do, we will find in our settings and folder management, looks like we're already there. Let's reload. A third application, Splunk TA NICs Lite. Here is our light version of our application that we can choose to ship out to other forwarders. So let's set up a server class. We'll say new server class. Let's imagine this light version is designed to go perhaps on Linux, let's say workstations, or Linux, let's say web servers. Let's say this light version is only designed to go on web servers. We only want to grab a subset of the information on our web servers. We'll do Linux _ web server and save it. We will add our Linux TA NICs Lite and save it. And in this case, I'm going to imagine that I have not yet set up and connected my forwarder for the TA NICs Lite. We're simply getting the configuration staged and ready for when I go and set, configure, and connect, all of those up and into Splunk. So hopefully a very simple and followable demonstration there for the team and how we would get our head around configuring the deployment server and pushing out applications. Key thing to keep in mind here, both of the add-ons, both of the server classes here that I configured only have one application being leveraged, right? We have one server class that pushes out our light Linux, our web server Linux, one that pushes out our generic Linux, our standard. This is what we want to grab from the standard Linux device, and one that pushes out our all outputs. It is by no means a requirement that each server class maps to one application. As you can imagine, perhaps we've got a Windows device and I want to add on the Windows add-on from Splunk Base, but perhaps on the same system, the same exact system, I have an IIS server. I want to add the Splunk add-on for IIS there as well. So server classes can map multiple packages of configuration to sets of clients. Certainly a lot we can do there with the deployment server, and I hope that the demonstration portion of today's call helped you get your head around how do I begin to plan this stuff out? How do I start to assign it to, is this agent-based? Is this HTTP-based? Is this syslog-based? And then make a game plan for getting the configuration pushed out to the individual systems. One last thing that I'll mention. If you recall, the only thing we had to do on the forwarder, the only setup we had to do was, let's actually wipe our screen. We had to go to our op directory. We had to install this TGZ, and we had to run one Splunk command. So we do cd Splunk forwarder in Splunk, maybe not cd. We'll do Splunk forwarder in Splunk at deploy -pull. Now, perhaps you find yourself in a situation where you have 400 devices you're pushing this out to and you're just getting it set up. Maybe you don't even want to have to set up the Splunk forwarder on all of them. In that case, deployment services, things like Ansible, whatever deployment service you choose to use, right? Many different flavors out there we could list. All you need to do is configure this application, this Splunk forwarder agent, to be installed and for this single command to be run on the Splunk forwarder. So we'll very commonly see that when customers first set up, first onboard Splunk. You've got 72, you've got 400, whatever the case would be. You've got many devices. You do not even want to have to visit each and set up that Splunk forwarder, wget on each. Use something like Ansible. Use some third-party application delivery tool to push it out with the necessary configuration, and you're good to go. So even simpler when we're talking about pushing out the forwarder there. But awesome. That wraps up the demonstration portion. So let's hop back into the presentation itself and keep moving forward. Now, Stuart mentions a great point. We had a Q&A here from Stuart Krivis. He said, wouldn't it be better to break out your various versions of inputs.conf for TA-Nix into separate inputs apps rather than having multiple versions of the TA-Nix app itself on the deployment server? Stuart brings up a great point. That would be best practice when we're talking about making multiple versions of inputs.conf, separating them out into single applications and keeping a single version, a single source of truth. When we talk about the Nix application, for demonstration purposes today, we did show you us simply copying that. But Stuart, great catch there, great point. When implementing multiple versions, it's best once you have that understanding of what those inputs.conf files do, what those individual configuration files do, to only copy those over into separate versions. Thank you, Stuart, for the comment there. Moving forward, additional resources. What can you get after today's call? We've got some training and certification that can really push you forward here. If you're a starting admin and this is one of your first time seeing the deployment server, you may also be in the case where, or be in the situation where you don't understand yet the different services involved in Splunk, regardless of that's Splunk Enterprise or Splunk Cloud. We've got courses for you there. We've got documentation attached that will list, again, all the commands we leveraged today. So that's deployment server documentation will show all the commands I leveraged, and the Splunk validated architecture brief will additionally list the architectures I showed you today. If perhaps you're curious and that piqued your interest seeing the snippets that were in the call. I've also got a link here to Splunk Lantern. Now, Splunk Lantern has many resources all the way from configuring your deployment server to load balancing Splunk to setting up search head or indexer clustering, and is a great place when you're in the boat where you say, hey, I'm just getting started. I don't really know exactly where to start. Splunk has a plethora of documentation. I think sometimes the only complication can be there's so much good documentation, you don't know where to start. So hopefully today's call, giving you that idea of where to start based upon your particular data source in combination with Splunk Lantern, which I definitely recommend you take a look at, will really get you pushed into the right direction. Now, I know on today's call, we didn't have time to get to all of your questions. I'm about to hop into a quick 5-minute Q&A session to answer some. If your question doesn't get answered today, don't worry. We'll certainly get an answer pushed out to you via the community.splunk.com. So if you do visit community.splunk.com, I believe there's a turnaround of about 5 days to a week. You'd expect all the answers to be gotten to by that point. So around next Thursday, next Wednesday, you should see your answer on community.splunk.com, specifically the deployment server tech talk that you attended today. That being said, let's hop into a quick Q&A session. I'm going to try to catch up here on some of the chat, so give me just a moment. It may take me a second to find some of these questions. So Stuart asks another question. Is it recommended to make the DS also its own deployment client, or should any apps on the DS be installed into? So Stuart, that's a bit of a nuanced question. I'll try to get to that one with a formal response by next week for you there on community.splunk.com. Now, Jeff Pico asks, what is the best practice for keeping apps add-ons up to date on the DS since you can't use the web UI to keep them up to date? What is best practice there? So if I'm looking to keep these applications up to date, what I typically do is I will, like I did on today's call, I will update the application in the UI. That way I don't have to actually SCP over anything. I'll update it in the UI, which pushes it to the apps directory, given that your deployment server should not also be a forwarder, right? It should be its own standalone system. That won't conflict with any applications, and then you can update them in place, right? You can push them from the apps directory into the deployment apps directory. I'll give you another reason, Jeff, to circle back on that. If you recall at the beginning of today's call, I recommended that you forward your deployment server logs to Splunk. What's the reason behind that? If the applications that you install in the deployment server you install via the UI, that means that Splunk has a listing of those applications, and you can check that at _internal. So when you run checks for old versions of applications on your monitoring console, on your search head, you'll also see them for the deployment server, which will immediately signal, hey, maybe I want to go out and update those. Hopefully that gives you a bit more information there. Now, Theodore, you mentioned a question there. Are there any, Theodore Waddell, appreciate the question. Are there any plans to add a UI option to update deployment apps like you can for apps? So not part of the software team here, so I am not certain if that is in the works. That being said, we can certainly get you a link to ideas.splunk.com to submit that as a formal report. And I'll also personally reach out to our FDSE team, our forward deployed software engineer team, and see and check for you if I am able to find any information out on that. Jerry Dalton mentions one last question here. I know we have about a minute left. Jerry Dalton mentions, how about when you have a more complex infrastructure and multiple deployment servers to share load? You cannot use the GUI. I'm not sure I fully get your question there, Jerry. Let me follow up with you post-call on the community forum and see if I can get you a more detailed response. Certainly, I would say I typically manage the deployment server via the CLI regardless, right? All of the update and push out commands that I showed you today have relevant configuration files as well. So if you were someone that said, I can never touch the GUI, you can certainly still fully manage the deployment server. You would just need to give the relevant commands and modify the relevant configuration files. All of that information will be found in deployment server and deploymentclient.conf. which the documentation we listed on today's call about the deployment server shows you. So certainly recommend, if you plan to do everything via the CLI, that you take a look at the deployment client and deployment server.conf.spec files, which will show you all the possible configurations that you can do there. I know we're running up against time. I really appreciate everyone today taking the time to join today's call. I really hope you got some useful information out of today's call, and I look forward to getting your questions answered and hopefully corresponding more as we move forward. One thing I'd mention as well is I personally am assigned to specific customers as well. And so what I would recommend is some of these questions that you may have, I'm certainly going to get you an answer here, but also recommend you bring them up to your account team. Your account team can likely give you an in-depth answer as well and help you out for the more architectural planning, inputs gathering issues that you may run into. But again, thanks again, team. Excited to connect further, answer some of these questions. And again, really appreciate you taking the time. Talk soon.